Hi everyone, I'm Cheryl. In this problem, we're going to be evaluating the trig functions of an angle whose terminal side passes through a given point. In our first example, our terminal side passes through the point 3, 4. When we look for the trig function values, they will all be ratios of the x-coordinate 3, the y-coordinate 4, and the length of the segment that goes from the origin out to that point. So I have the 3 and the 4, but I need to figure out what this length is to help me with all of my trig functions. Well, how do I find that? Well, I notice that I can create a right triangle by going from the ordered pair down to my x-axis. And notice what happens. This side of my triangle, which is the x-coordinate, has length 3. This side, which is the y-coordinate, has length 4. Because it's a right triangle, I can use the Pythagorean theorem to figure out the hypotenuse side. So let's go ahead and do that. I'm going to say that r equals the square root of x squared plus y squared. Now this may not look like the Pythagorean theorem at first, but notice if I square both sides, I get r squared equals x squared plus y squared. Okay, so let's go ahead and fill in the information. I know that x is 3, so I have 3 squared. I know that y is 4, so that's 4 squared. So I've got the square root of 9 plus 16, which is the square root of 25, or 5. So I know that that hypotenuse has length 5. I have all the pieces I need now to find all 6 trig function values. So let's begin with the sine. The sine of theta is defined as y divided by r, as long as r is not 0, and I know that's not the case here. So the y-coordinate is 4, the r-coordinate is 5, and I have 4/5. Go ahead and look at the cosine of theta. The cosine of theta is defined as x divided by r. X is 3, r is 5, and so the cosine of theta is 3/5. The tangent of theta is defined as y over x. The y value is 4, the x value is 3, so the tangent is 4/3. Okay. We have 3 more trig functions to go. They're all the reciprocals of the ones that I've shown already. But let's go ahead and take a look at them by definition. The first one is the cosecant of theta. By definition, the cosecant is r over y. The r value I calculated to be 5, and the y value is 4. So my cosecant of theta is 5/4. Notice that's the reciprocal of the sine. The next one would be the secant. So the secant of theta is defined as r over x. Again, the r value is a 5 and the x value a 3. So the secant of theta is 5/3. Again, take a look, that's the reciprocal of the cosine. Last one is the cotangent of theta. The cotangent is defined as x over y. The x value is 3, the y value is 4, so the cotangent is 3/4, which again, just checking to make sure it all makes sense, it's the reciprocal of the tangent. Okay, let's try it again for a different angle. This time, the ordered pair that's on my terminal side is the point -12, -5. So this is the angle that I'm going to be using. It's not an acute angle this time. However, I still need the same 3 quantities. I need the x-coordinate and the y-coordinate, which have been given, and I need this length. Again, I can find the length between the origin and my ordered pair by creating a right triangle. And I'm going to bring a vertical line down to my point. In the triangle, you can see that this side, which represents the x-coordinate, is going to be -12. This side, which is the y-coordinate, will be -5. Now, to find this length r, we're going to use the Pythagorean theorem as we did before. I'm going to write r as being equal to the square root of x squared plus y squared. This time the x-coordinate is negative 12, so I have negative 12 squared. The y-coordinate is negative 5, so I have negative 5 squared. This is going to be the square root of 144 plus 25, which is the square root of 169, or 13. So r is 13. Now we're ready to go ahead and evaluate all of our trig functions. So we'll begin again with the sine of theta. The sine of theta, by definition, is y over r. Y is going to be negative 5. R is 13. So we have the sine of theta is negative 5 over 13. The cosine of theta, on the other hand, is x over r. Our x value is negative 12, and again, r is 13, so the cosine of theta is negative 12 over 13. Tangent is next. The tangent of theta is defined as y over x. The y value is negative 5, the x value negative 12. Okay. Notice this one can be reduced. Instead of writing it as negative 5 over negative 12, I'll just write it as 5/12. Okay, we've got the first three trig functions down. The other three are reciprocals of the ones I've already done. So let's go ahead and look at the cosecant of theta. By definition, the cosecant is r over y. R in this case is 13, y is negative 5, and I have negative 13 over 5, which is the reciprocal of my sine. Secant is next. The secant is r over x. Again, the r value is 13. The x value is negative 12. And so the secant of theta is negative 13 over 12. And again, notice reciprocals here. Last one is the cotangent of theta. The cotangent by definition is x over y. The x value is negative 12. The y value negative 5. Negative 12 over negative 5 can be reduced to 12/5, and again, it's the reciprocal of the tangent. I hope that was helpful. Thanks.